in a way, is a consequence of our success in controlling our environment. In our evolutionary history, people didn't age. There was no Alzheimer's, no cancer. There was just people dying of starvation and infection and predation and lions jumping out of the savannah.
The reason we live the length that we do is that that's the time it takes for us to be able to make enough offspring to replace ourselves successfully. And for humans, that's about 40 or 50 years old. After that, you're at the whim of entropy, our bodies fall apart.
What has happened is we've managed our environment. We've conquered the major infections that used to curtail our lifespan. We have a lot of control over our food supply. We have control over our climate, et cetera, et cetera. And as a consequence, we're not dying of these extrinsic hazards. So we're living long beyond the time frame that evolution had to act to keep us healthy. So a subtext to this evolutionary theory of aging is a process that has been termed antagonistic pleiotropy. What's good for you when you're young can be bad for you when you're old. So the first example was calcium in your blood. You need calcium in your blood. You break a bone, you want that calcium there to help heal that bone fast. That's great when you're young, but as you age, that calcium slowly deposits into your arteries and you get arterial stiffness, classic symptom of aging. Same thing is true of testosterone in males. It's wonderful, right? Stronger muscles, bigger bodies. And yet, if you are a male over the age of 50 or 60, you will almost 100% have prostatic hyperplasia and you're at risk for prostate cancer, byproduct of testosterone.
Many of the processes that we study in aging are actually important in early life, for development, for reproduction. And it really tells us something about the evolutionary origins of aging, that actually the genes, the processes that determine how fast we age, are really important for other stuff. So that throws up the question, well, you guys are in there and talking about changing aging rate and interfering with these aging processes, but you're also telling us that they're important for other stuff. And actually I think it's really important that we understand that some of the processes of aging could be beneficial in early life, and we need to understand how and why they're beneficial and ensure that we're not making an intervention that's going to be detrimental to early life.